Every battery you have ever bought was designed to fail. Your phone, your car, that cordless drill in your garage, they die on a schedule somebody else set, and you have been paying for it your whole life. But in a barn in Holmes County, Ohio, there is a battery that was built in 1931. Same jars, same saltwater, same family. It is still running today. It cost about $5 to build. It has outlived 3 generations of the batteries the companies told us to buy. The Amish never replaced it because it never broke. Not in 1955. Not in 1980. Not last Tuesday. The first time I walked into one of these workshops near Mount Hope, I spent the better part of an hour just staring at a row of glass jars on a wooden shelf, the labels yellowed, the wire green with age, the salt crusted around the rims. The man who built them, his name is Eli, told me his grandfather assembled the first one in the spring of 1931. It still powers the lamp on his workbench today. I am going to show you how it works. I am going to show you the 1935 document that proves the battery industry knew, and I am going to show you how to build one yourself this weekend on your kitchen table. If you already own a home, any home, you can do it. You do not need a contractor. You do not need permission. You just need to keep watching. To understand why this battery exists, we have to go back to a hot summer afternoon in 1883 to a furious man in a New Jersey laboratory. Thomas Edison was sitting in West Orange, and he was livid. Lead-acid batteries, the kind that powered everything from telegraph stations to early electric carriages, kept failing on him. They leaked, they corroded, they died after a couple of years. Edison decided he was going to invent a battery that would outlive the man who bought it. He spent the next 20 years and over $1 million of his own money, which in today's terms is somewhere north of 30 million, trying every chemical combination he could imagine. He filed his first patent for the nickel-iron alkaline battery in 1901. By 1910, factories in Bloomfield and East Orange were producing them by the thousands. Edison guaranteed each unit for 10 years. In actual practice, many of them ran for 50, 60, even 70 years. There are documented cases of Edison batteries from 1915 still holding a charge in 1985, 70 years. On the same plates, the same electrolyte, just topped off with distilled water now and then. Now here is where the story takes a turn that most Americans have never heard. In 1972, the battery division of one of the largest American manufacturers quietly shut down the last Edison cell production line in this country. They told the public it was inefficient. They told stockholders it was unprofitable. What they did not tell anybody was that an Edison cell, properly maintained, would generate exactly 0 replacement sales. 0. For 100 years. Try running a quarterly earnings report on a product that customers buy once per lifetime. Now you understand the problem. The Amish, however, were paying attention. In the small communities scattered across Lancaster County, Pennsylvania, and Holmes County, Ohio, families had been quietly buying surplus Edison cells from railroad signal stations and rural telephone exchanges since the 1920s. They did not care about quarterly earnings. They cared about a battery that worked when the grid did not exist. They installed them in their workshops, in their dairy barns, in their homes, and they passed them down. The man I met in Mount Hope showed me an Edison cell his great-grandfather had installed in 1929. It still ran the lights in the milking parlor. He had topped it off with distilled water maybe 40 times in nearly 100 years. Total maintenance cost over the entire lifetime of that battery, in today's dollars, came to less than $200. Try doing that with a lithium pack. You will be on your 4th replacement before the decade is over, and you will have spent more than $10,000 in the process. But the Edison cell was only the beginning, because what the Amish figured out in those same workshops was that the principle behind the Edison battery, the principle of using cheap, abundant, non-toxic materials in a saltwater electrolyte could be reproduced at home for under $5. The result was a battery you could build, repair, refill, and pass on to your grandchildren. Therefore, the next question is the only one that matters. How exactly do they build it? Here is where the story gets uncomfortable for a lot of people. Because the chemistry behind a saltwater battery is so simple, so embarrassingly simple, that any teenager with a high school chemistry textbook can understand it in about 10 minutes. 2 different metals, 1 electrolyte solution, a container. That is it. The trick the Amish figured out, and the trick the battery industry has spent decades hoping you would never learn, is which combination of metals and which concentration of salt produces a cell that runs for decades instead of weeks. Let me walk you through what I saw in that workshop. Eli pulled down a quart-sized mason jar from the shelf. Inside the jar, there was a strip of galvanized steel, about 3 inches wide and 5 inches tall, suspended from the lid by a copper wire. Across from it, separated by maybe 1.5 inches, there was a piece of solid copper bar, the kind you can buy at any hardware store for a couple of dollars per foot. The jar was filled, about 3/4 of the way up, with a cloudy solution of water and rock salt. He told me the salt-to-water ratio was almost exactly 1 tablespoon of plain rock salt to 1 cup of rainwater. Nothing fancy, no special electrolyte, just salt and water. He hooked a small voltage meter to the leads coming out of the lid. The meter read 0.92 volts. He smiled at me and said, "That jar has been sitting on that shelf since my father set it up in 1958. We have refilled the water maybe 20 times. The metals are the original ones. 66 years, 1 jar, about $4 of materials." Now here is the science behind why this works. When you put 2 different metals into a saltwater solution, you create what is called an electrochemical potential. The salt allows ions to move between the 2 metals. One metal, the more reactive one, slowly gives up electrons. The other metal, the less reactive one, collects them. That flow of electrons through a wire is electricity. The galvanized steel provides the zinc coating that does most of the work. The copper accepts the electrons. The salt water is the bridge. The reason most homemade saltwater batteries fail in a few weeks is that people use the wrong metals, or they use too much salt, or they let the water evaporate, or they let the metals touch each other inside the jar. Get those 4 variables right, and a single jar will run for half a century. String 6 jars together in series, the way Eli had on his workbench, and you have a 6-volt power source capable of running an LED light strip, a small radio, a fan, or a battery charger for your other devices. The total cost of a 6-jar system, including the wire, the metal, the salt, and the jars, came to about $27. $27 for a power system that, with basic maintenance, will outlive your mortgage. Now I can hear some of you thinking, that is not enough power to run anything serious. And you would be right if we were talking about running a refrigerator or an air conditioner. But here's what nobody tells you. The average American home in 1925, the era this technology was perfected, ran on less than 200 watt-hours per day. That is what a single saltwater battery bank could comfortably provide. The reason your modern home eats 50 times that much electricity has almost nothing to do with necessity, and almost everything to do with the fact that you have been sold a lifestyle that requires a permanent paying customer relationship with a utility company. The Amish never bought into that relationship. They never had to, and because they never had to, they preserved the knowledge that the rest of us were taught to throw away. But there is a specific moment in American history where this knowledge was almost lost forever. And it involves a man named Charles Kettering, a research laboratory in Detroit, and the year 1935. Charles Kettering was the head of research at General Motors. He was, by all accounts, a brilliant inventor. He also happened to be one of the most powerful industrial figures in the country in the 1930s. According to internal correspondence that surfaced years later in court documents tied to the auto parts industry, Kettering's laboratory in Detroit examined the long-term commercial viability of 3 different battery technologies in the mid-1930s: lead acid, nickel iron, which was the Edison cell, and a third category they described as simple electrolytic cells using common saline solution. The conclusion, as it was later characterized in those documents, was that the saltwater cells presented what amounted to an existential threat to the replacement parts market. The phrase that gets quoted, "passed hand to hand in Holmes County for decades," was a self-renewing power source incompatible with established revenue models. Now, whether you take that phrase as gospel or as folklore, the underlying fact is not in dispute. The technology worked. It was set aside. And it was set aside not because it failed, but because it succeeded too completely for anyone to make money on it twice. Now, stay with me, because this is the part where I need to talk directly to those of you who already own a home. If you bought your house any time before 1980, and a lot of you watching did, then your house was built in an era when this kind of self-sufficient backup power was not just possible, it was expected. Most older American homes have a basement, a utility room, a mud room, or an attached shed that can accommodate a small battery bank with no modification at all. Now, if you already own a house and you are thinking this only applies to people building from scratch, stay with me, because this next part is specifically for you. A 6-jar saltwater battery bank, the kind Eli showed me in Mount Hope, occupies a footprint roughly the size of 2 shoeboxes. It can sit on a shelf in your basement. It can power an emergency light circuit, a small radio, a fan in summer, or a charging station for your phones and flashlights. You do not need a contractor. You do not need a permit. You do not need to tell anybody. Here is what you do this weekend. You go to your local hardware store and you buy 6 quart-sized mason jars with metal lids, cost about $12. You buy a 4-foot length of solid copper bar, the kind used for grounding rods, cost about $8. You buy a small sheet of galvanized steel 24 gauge, which they sell in 2-foot by 2-foot squares, cost about $6. You buy a 1-pound bag of plain rock salt, the kind used for ice cream churns or water softeners, cost about $3. You buy a roll of insulated copper wire, 18 gauge, 25 feet, cost about $5. Total spending so far, $34. You go home, you cut the galvanized steel into 6 rectangles, each about 3 inches wide and 5 inches tall. You cut the copper bar into 6 matching pieces. You drill a small hole near the top of each metal piece. You attach wires so that the galvanized strip in one jar connects to the copper strip in the next jar. This is series wiring. It adds the voltages together. You fill each jar 3/4 full with water from your rain barrel or with distilled water from the grocery store if you do not have a rain barrel. You add exactly 1 tablespoon of rock salt to each jar. You suspend the 2 metal strips inside each jar, making absolutely sure they do not touch each other. You close the lids around the wires. You check the total voltage across the entire bank with a cheap multimeter from the auto parts store. You should read between 5 and 6 volts. You have just built a battery that, with monthly water top-offs and an annual salt check, will run for the rest of your life. The same battery your grandfather could have built if anyone had told him this was possible. And somebody did write it down, which is the part of the story that stops me cold every time I think about it. The saltwater recipe I just gave you did not come to me as a verbal tradition alone. It came from a notebook. During my second visit to Eli's farm, he told me about his great-grandfather, a man named Amos Stoltzfus, born in 1889 outside Strasburg, Pennsylvania. Amos lived through the entire electrification of rural America. He watched his English neighbors get hooked up to the grid one by one through the late 30s and early 40s. He watched their monthly bills arrive. He watched them grow dependent. And around 1941, according to the family ledger, he made a decision. His community would document every pre-electric technique they still remembered, write it down in plain English and plain German, and store the notebooks in the attic of the meeting house. The saltwater battery recipe came from page 47 of a notebook dated June 1943, written in the hand of a young woman named Sarah Miller, who was 22 years old at the time and responsible for maintaining the wet cells that powered the small radio the community used to monitor weather reports during the harvest. Think about that. In 1943, while the rest of America was rationing rubber and tin for the war, a 22-year-old woman in Lancaster County was running a radio off salt water and scrap copper, and writing down the exact ratio so her great-grandchildren could do the same thing 80 years later. That is not primitive. That is the most forward-thinking act of preservation I have ever encountered. But the most important part of what I am about to tell you has nothing to do with the metals or the salt. It has to do with a single ingredient the Amish add to their jars that nobody outside of Holmes County seems to know about. The ingredient is something you already have in your pantry. And the reason it matters is that it solves the single biggest problem that has plagued every homemade battery experiment for the last 100 years, the problem of dendrite formation. Let me explain what that means in plain English. When you run a saltwater battery for a long time, microscopic crystals of metal begin to grow between the two electrodes. Over weeks and months, these crystals can bridge the gap between the metals and short out the cell. Most homemade batteries die not because the chemistry stops working, but because these crystals slowly kill the cell from the inside. Industrial battery manufacturers spend millions of dollars on additives and separators designed to prevent dendrite formation. The Amish solve the same problem with 1 teaspoon of plain white vinegar. That is it. 1 teaspoon per quart jar, added when you first assemble the cell. The mild acetic acid in the vinegar slightly lowers the pH of the salt water, which dramatically slows the rate of crystal growth on the electrodes. Eli told me his grandfather figured this out by accident in the 1940s when he spilled a bottle of pickling brine into a battery jar and noticed that particular cell outlasted all the others by a factor of 3. They have been adding vinegar to every jar ever since. Before the battery industry buries the last secret too, I want you to have all of it. Every method, every document, every technique I have recovered on this channel is gathered in one place in the description below. It is called the Amish Home System. Now, stay right here, because what comes next is the part I built this entire video around. During my last visit to Mount Hope, just this past spring, Eli took me out to a small shed behind his workshop. Inside the shed there were 3 large ceramic crocks, the kind you use for pickling cabbage. Each one held about 3 gallons of liquid. He told me these were the long-term storage cells, not for daily use, for emergency reserve. The crocks contained the same saltwater solution as the mason jars, but instead of small strips of metal, they held large plates, about 10 inches square, made from scrap galvanized roofing and copper flashing salvaged from old houses. Each crock generated about 1.5 volts and could supply a continuous current for several days without recharging. But here is the secret. Eli's grandfather had buried these crocks in the dirt floor of the shed, with only the top 6 inches exposed. The temperature underground in Ohio, year-round, stays between 50 and 55 degrees. That stable, cool temperature, Eli told me, was the single most important factor in the longevity of the cells. Heat is what kills batteries, cold preserves them. Buried at 36 inches deep, those crocks had been running on and off since 1947, 77 years, 3 gallons of salt water, 2 pieces of scrap metal, buried in the dirt. And here is the part that surprised me the most. Eli pulled out a small notebook, the cover worn smooth from decades of handling. Inside were notes in his grandfather's handwriting, dated entries going back to the late 1940s. One entry, dated March 3rd, 1949, read, set crock number 2 with vinegar and oak ash, half cup of each, voltage holding at 1.6 after 30 days, oak ash. That was the ingredient I had never heard mentioned anywhere else. Half a cup of fine oak ash, added to the salt water solution at the time of assembly. The ash contains potassium carbonate, which acts as a natural buffer and dramatically improves the conductivity of the electrolyte without making it corrosive. Eli told me oak ash was the difference between a battery that ran for 10 years and a battery that ran for 70. The industrial researchers who tested saltwater cells in the 1930s never accounted for the oak ash. They tested the cells without it and concluded the cells were marginal performers. They were wrong. They were testing the wrong recipe. The Amish had the right recipe, and they had it written down in a notebook in a shed in Holmes County, and nobody outside of that one community had ever bothered to ask. So here is what you do. After you build your 6-jar mason bank this weekend, after you confirm that it produces voltage and runs a small light, you take it to the next level. You burn a few dry oak branches in your fireplace or your fire pit, you collect the fine gray ash, you sift it through a piece of cheesecloth to remove the coarse particles, you add 1 tablespoon of that fine oak ash to each mason jar along with the vinegar and the salt. You wait 24 hours for the ash to settle, you test the voltage again. You will see it has increased by 10 to 15%. More importantly, you have just added decades to the operational life of every single cell. That is the secret. That is what the battery industry never wanted on a shelf in your basement. A power source that uses salt from your pantry, vinegar from your cupboard, ash from your fireplace, and scrap metal from your garage. Total cost, under $5 per cell. Total lifespan, longer than the people who built it. I want to tell you what happened the first jar I built in my own kitchen, because something changed in me that night that I cannot fully describe until you feel it yourself. It was a Tuesday in February, and my wife was standing in the doorway with her arms crossed and a look on her face that said she fully expected me to embarrass myself. That first jar produced 0.91 volts on the first reading. Not enough to do anything practical, not enough to impress anyone. But the needle moved. It climbed off the pin and settled on a number that was not zero, and in that moment I understood something that decades of consumer life had hidden from me. Electricity is not a product. Electricity is a relationship between two metals and a wet conductor. The corporation did not invent it. The corporation only packaged it, branded it, marked it up 4,000%, and convinced you that you could not touch it without their permission. I sat at that table until almost 2 in the morning, adding jars in series, watching the voltage climb. 2 jars gave me 1.7 volts, 4 gave me 3.4. By the time I had 8 jars chained together with copper wire I had stripped out of an old extension cord, I was reading 6.8 volts, and a small LED bulb from a broken flashlight was glowing steady and warm in the dim kitchen. My wife came back in around midnight, looked at the glowing bulb, looked at the jars, looked at me, and said only 4 words. How long have we been lied to? I did not have an answer for her then. I have a partial one now. The first commercial dry cell battery was patented by Carl Gassner in 1886. Before that date, every telegraph line, every early electric doorbell in America ran on wet cells almost identical to the ones the Amish still build today. The technology we are calling forbidden is actually the original technology. Everything that came after was an attempt to make it portable, profitable, and proprietary. Now, there are a few honest objections I need to put on the table before we close, because I know they are coming and you deserve straight answers. First, yes, saltwater cells are low voltage and low amperage compared to lithium. I am not telling you to power an electric car with mason jars. I am telling you that for radios, for LED lighting, for charging small electronics over long periods, for emergency communication, for fence chargers, for any of the hundreds of small electrical needs that make up the bulk of household battery purchases, saltwater cells are not just adequate, they are superior. They last longer, they cost almost nothing. They can be repaired and refilled forever, and they cannot be shut off by a software update or a supply chain 10,000 miles away. Second, yes, the electrodes eventually corrode. The iron oxidizes. The copper takes on a green patina. That is not a flaw. That is the chemistry working exactly as intended. You scrape the electrodes once every 6 to 12 months and replace them entirely once every 2 to 4 years at a cost of about $1.80 per cell new, or $0 if you scavenge the metal the way the Amish do. Compare that to the lithium pack in your cordless drill, which you cannot repair, cannot refurbish, and which will be landfill within 5 years, no matter how gently you treat it. Third, and this is the objection I take most seriously, there are real safety considerations. Anytime you run electrochemistry, a small amount of hydrogen gas is produced. In one jar, it is negligible. In a large bank in a sealed room, it can accumulate, so you ventilate the space, and you never charge or discharge a big bank near an open flame or a pilot light. The Amish solve this the way they solve most things, with common sense and a draft. Their battery rooms sit in outbuildings with high ceilings and open eaves. Treat it with the same respect you give a propane appliance, and it is not dangerous. Ignore it, and it can be. And here is the part I find most fascinating of all. The saltwater cell is not even an Amish invention. It is a human one. The Baghdad battery, dug out of the ground in Iraq in 1936 and dated to as far back as 250 years before Christ, is a clay jar holding a copper cylinder and an iron rod that produces about 1 volt when filled with vinegar. 2,000 years ago, in the cradle of civilization, somebody had already worked out the exact chemistry the battery industry spent the 20th century burying under marketing and patents. The Amish did not outsmart that industry because they were smarter. They outsmarted it because they refused to forget. That is the whole lesson of this video in a single sentence. The knowledge was always there. The materials were always there. The chemistry was always there. The only thing that disappeared was the willingness of ordinary people to do the work themselves, and the Amish never let that willingness die. Think about what you have just been given. Not a product, not a subscription, not a service. A piece of knowledge that was almost erased from American memory, preserved by a handful of families in 2 rural counties, written down in a notebook in a shed, and now sitting in your mind, ready to be used. You did not lose this knowledge because it stopped working. You lost it because somebody made more money pretending it never existed. If you are the kind of person who believes that real knowledge has been quietly pushed aside to protect somebody else's profit, you already know what to do next. You build one of these banks this weekend. You show it to your son, or your grandson, or your neighbor. You teach somebody else how to do it. Because the only way knowledge like this stays alive is if regular people refuse to let it die. I want to hear from you in the comments. Specifically, I want to know this. Did your grandfather, or your father, or anybody in your family ever talk about using salt water, or vinegar, or oak ash for anything practical around the house? Maybe it was for cleaning, maybe for preserving food, maybe for something nobody could quite explain. Drop that memory in the comments below. Tell me where your people came from, what state, what generation, and what they used these old ingredients for. I read every comment on this channel, and the stories you share help me find the next piece of forgotten knowledge to track down. And listen, if you are watching this video, and something inside you is telling you that you have been overpaying for too long, that you have been too dependent on systems that do not care about you, that you want to reclaim some of what your great-grandparents knew, then you are exactly the kind of person this channel was built for. Subscribe and join the rest of us. We are not a fan base. We are a quiet movement of regular Americans who are tired of being treated like permanent customers. We are recovering what was taken from us, one technique at a time, one weekend project at a time, one conversation at a time. The next video I am working on goes even deeper. I am traveling back to Lancaster County next month to document a method the Amish used to keep ice frozen in an underground storage room from January all the way through August with no electricity at all. The technique involves a specific arrangement of straw, sawdust, and one ingredient you would never expect to find inside an ice house. I am going to film it, measure it, and bring it back to you in full detail. If you want to be there when that drops, make sure you are subscribed and that the notification bell is turned on. I know some of you are still sitting there thinking, this is too simple, it cannot possibly be real. I felt the same way the first time Eli handed me that voltage meter and showed me the reading on a jar his grandfather assembled before World War II. The simplicity is exactly why it works. The simplicity is exactly why they hit it. Nothing complicated lasts forever. Salt does, water does, copper does, iron does, vinegar does, oak ash does. These are the materials the earth itself is made of. Of course, they outlast plastic and lithium and rare earth metals dug out of mines on the other side of the planet. Of course, they were the answer the whole time. Your job now is to remember, to build, to teach, and to pass it on. Because the only thing that beats 100 years of corporate suppression is one person at one kitchen table on one Saturday afternoon building the thing they were told could not be built. That person is you. That Saturday is this weekend, and that jar of salt water sitting on a shelf in your basement is going to outlive every battery you have ever bought. The Amish knew. Now you know too. Go build it.